we are given that AQ is parallel to RT. Then VQ over QC is going to be equal to 3 over 5. So straight away, it's better to start using those ratios. Okay, so you got your diagram. BQ is this length here. So I'm going to call it 3K. So that will be my 3K. Right? And then QC, I'm going to call it 5K. So that whole length there is going to be 5K. Okay, but here I've got K already in the question, so it's not a wise idea to use K. So allow me to just remove this. No, I don't want to do that. Okay, if you use K yourself, it's fine, but I don't want to use K. Right, please remember, K is just a constant. So you can use any other letter, it won't make a difference. I don't want to have a conflict with this K here. So I'm going to call it 3Y. Okay. And then this one here, I'm going to call it 5Y. Okay. And then BR over RA. BR what?
If you use another constant, when you're doing the 4.2, you're gonna get us.
Don't worry. Don't worry about it. Okay, I see what you mean.
Yeah.
Okay, but still we can have a range between Y and K. Okay, you can have a range between Y and K. Alright? So don't worry. So the length, this one here is given as K. Okay, but I think to avoid confusion, what she's saying is right. Right? No, it makes sense. Yeah, it makes sense. Okay, so let's call BQ, let's call it BK. It makes sense. Right? And then this one here to be K, that's BT. And then QC is going to be 5K. But we can also use a different letter and come back, but that will be a longer route. Alright, so BT is equal to K. We need to calculate what the length of TQ is. Okay? Now, to calculate TQ, once you've got it, it's 2 marks, right? So, by using that ratio there, okay, you can find what TQ is. Okay? So you have to indicate this on your diagram, which means TQ is going to be equal to 3K minus K, and you get what? 2K. So this will be 2K. But you have to indicate that on your sketch, how you end up coming up with this 3K. So you have to indicate it on the diagram. Okay. Hello? Are you following that?
Why can you use the constant K for the ratio between BQ
Between BQ and what?
why can you use anything? You don't necessarily know that BT is twice TQ. You don't know that.
Okay. But because we have this constant here, right? We have this constant. Remember, the constant here is not a length, right? Okay, this K here, it's actually, in this case, it's going to be a length, right? This K is going to be a length. But because I called this distance from B to Q, I called it 3K.
But why do you just call it 3K? You don't know that BQ is 3 times K. No, it doesn't say that anyways. You don't know that.
It just says BT.
All right. Okay. To avoid the conflict with what with this argument that you are bringing, right? Allow me to go back to a different letter. Okay. Can I have your attention? Okay, because they are arguing that since K here, it's a specific length, we don't really know the length of BQ in terms of K. So to avoid that conflict, okay, I know that she was arguing about the fact that later you need the K, but we can connect two constants, okay? So let's move back to Y, right? Let's move back to Y. Right, so it means that length there. I can't erase this now. So let me try to just cover it up. Yeah, I won't be able to. So, okay, can I have your attention? So what this means is if this is K, if this length here, BT is K, we don't really know what is the length of what? Of TQ. In terms of K, we don't know. Right? So the only way that I probably have to do it is to use the proportion theorem. Right? Can you pay attention, please? Since I know the ratio of BR over RA, I'm going to use it, okay, to determine the length of TQ. Okay? So, allow me to just say, in triangle, I'm going to use triangle ABQ. In triangle ABQ, right? So I'll say BR over AR. Remember, it's your choice here to decide which one is your numerator, which one is your what? Denominator. So that will be equal to BT over TQ or QT. Then here you have to give your reason line parallel to one side of triangle. Right, so what is that ratio? Okay, BR, based on the information there, I'm gonna say this is BR is gonna be X, and that will be what? 2X. Okay? So that I can write this as 1 over what? 2. So that will be equal to K over TQ. Okay? Well, the good thing is we are going to come back to what I wrote initially, but because I'm a teacher, it is fair for me to leave you convinced when I'm doing what? The question. Right? Not to get to a point where someone will ask questions like that. Right? So if you cross multiply, you will get TQ equal to what? 2K. Right? But that's the correct maths now. Okay, that's the correct maths of doing it. Are you following? Okay? Now, what this means is if I put 2K here, it's going to mean that K is going to be equal to Y. Do you agree with me then? Yes. Huh? Yes. Do you agree with me then? Yes. Yeah, then it will come back to what I told you initially, that we can relate K and what? And Y. There's no problem with that. Okay? So what this means is eventually means K is equal to what? To Y. Okay, so we're going to carry on. Now, it means I can write this length here in terms of K as well. So it's also equal to 5K there. QC is also equal to what? 5K. Are you following that? Okay? So let's carry on. So when I do the questions going forward, I'm going to do them in terms of what? In terms of K, not Y. Right? So let's carry on. Now we are here. So we have got CP over PR. Okay? You need to determine the numerical value of CP over PR. So for this diagram, let me label it properly based on what I have now. After resolving the issue about the length. Okay, so this is going to be X, and that will be what? 2X. Once you have got this, you're almost done. Right? So we have got CP. Now our CP is from here all the way up to there, right? And then we have got PR, which is from here up to there. Now I'm sure you can see we can identify a triangle that we can apply the what? Proportion theorem. And what will be that triangle? It will be what? CRT. Do you all see that? Is there anybody who can see that? Right, so if you can all see that, then that's a good thing. So we say in triangle CRT, right? If you apply the proportion theorem, we want CP over PR. So I can write it as CP over PR. This is going to be equal to CQ over QT. And I have to give my reason here. Line parallel to one side of triangle. So CP over PR is going to be equal to CQ, okay, which is 5K, over TQ, which is what? 2K. So the final answer will be 5 over 2. Are you all following that? Yes. Right? So let's move on to the next question. Now, I'm not sure whether everyone did that question. Okay, let me bring it. Okay, but I've got it there. Okay, let me just drop this down a little bit. All right, I want you to pay attention carefully as I talk about this question. I'm not sure how you approached it, okay? But we have got two triangles, okay? So let's use our highlighter, okay? Let's use our highlighter. So we have triangle RCT. This is R, that's C, that's T. Okay, so that's the triangle. Then triangle ABC, which is the bigger one. Okay. So if I were to ask you, do those two triangles share a common vertex? Yes. Okay, the answer is a yes. Okay. So they share a common vertex here. But does that mean they share a common height? No. Now, since they don't share a common height, right, can we use the area rule? No. Okay, so for this question, they don't share a common height, so we can't say the ratio of their areas is equal to the ratio of their bases. Also, they don't share a common angle. Okay, now, just before I carry on, if you try to do the question, how did you approach it? Is there anybody who wants to tell us before I share with you how to approach the question? Huh? Is there anybody who wants to tell us how they approached it?
So please explain the common vertex thing. I always confuse it.
Okay. The way that I can explain this, a vertex is just like a point where an angle is created, right? Sometimes triangles can have a common vertex, which means, like in this case, we have BC, AC intersecting here. Also, we have RC intersecting with them, which means this becomes a common vertex for the two triangles. But the problem is that TR now is not along AB. TR is not along AB. Therefore, they can't have the same height. If TR was along AB, or if RB was like a base of that triangle, then we could say they have a common what? A common height.
Oh, so if they perform the vertex, then they have common base.
If the bases are along the same straight line. So in this case, the bases are not along the same straight line. So even though they share a common vertex, if you consider TR as your base, it's not along what? AB. So they don't have a common height. All right, can I have your attention, please? So some of you were not here yesterday. Now, so for this question here, you have to identify a third triangle which shares a common height with both triangles. So it's more like this. I'm sure in algebra you know that if I say x over y, right? If I want to introduce z, okay, I can write this as times. I can write this as okay. Let me write it as. So I can write this as z over y times x times x over what? Z.
Wait, so what is it?
No.
Please do me a favor. You need to pay attention. Okay? You need to pay what? Attention. So here, x over y, if I introduce a third letter, I can write it as z over y times x over what? Z. Because these two, they what? They cancel out. So when you're dealing with areas of triangles, in a case like this, where they don't share a common height, okay? You don't see any relation between the two. Try to identify a third triangle which is related to both. Okay? You have to identify a common what? Triangle, which is the third one, which you can relate to both of them. So can you tell me the triangle which shares a common height with both these two triangles?
ACQ.
Which will be what? Okay, you are saying ACQ.
I am guessing. I don't know.
It will be what?
I'm saying AB.
Alright, I'm gonna give you 1 minute. Okay. It will be what?
RBC.
Thank you. It's what? RBC. We want a third triangle which shares a common vertex and a common height with both triangles. These two.
Okay.
So if you look at RBC,
I just don't because I had a line together.
like if you look at RBC, it's this one here. Right? RBC in relation to ABC, they share a common vertex here. And also RB is along AB. Therefore, they share a common what? Height. If you look at RBC and TRC, they also share a common vertex at R. Right? It means their bases are going to be along what? BC. Do you see that?
Yes, so yeah.
Okay, I'm going to repeat it. Because of the nature of the question, so far we have only done two types of questions where two triangles share a common height and their bases along the same straight line. Though we say the ratio of their areas is equal to the ratio of their bases. Then we did a case where two triangles share a common angle. Then you use the area what? Area rule. Now this is another case which you can also encounter, whereby the two given triangles don't share a common vertex, sorry, they share a common vertex but not a common height. Right? Therefore, to determine the ratio of their areas, you have to determine a third triangle which is related to both. Okay? How will it be related to both? It must share a common vertex and also a common height with both of them. Okay? Once you identify that, the question becomes easy. Yes. Okay. Okay. If you look at RCT and CRB or CBR, right? Your common vertex is going to be that. So you can draw your perpendicular height all the way up to what? BC. Do you see that? Huh? Are you sure?
I think so. So it's
You can't say I think so.
yeah, I'm not sure. So
Yeah. There is a common vertex here, right? Which means we can draw a perpendicular height from the vertex to line what? BC. And that line will be the perpendicular height, which means they will share a common what? A common height, right? Then what will be the base? If this is the vertex, means the bases of both triangles, one of them is going to be TC, for the other one is going to be BC. Do you see that?
Sir, how is this for 3 marks?
Okay. Okay. You see, you might think it's that way because I'm taking a bit of my time to explain it. But when I start writing, you realize that it's worth 3 marks. The only problem is being able to figure out how to carry on. Okay. Can you raise your hand if you can see that CRB and TRC, they share a common vertex, therefore they're the same height? Do you see that? Right, can you put your hand down? I just want to tell you something. Geometry questions are all about what you see. If you don't see it, you're going to have problems. Okay? If you don't see it, you're not going to have problems.
Then what does C or B have in common with C?
Okay. Now, remember, this is C, R, B. They share a common vertex C.
Yes.
Right? And then BR is along AB. Therefore, I can draw a height from vertex C all the way up to AB. And that angle will be 90. I can draw a perpendicular height from vertex C because BR is along what? AB. Which means they also share a common what? Height. Therefore, the ratio of the areas will be equal to the ratio of their bases. Okay.
So triangle ABC and triangle, sorry, I just need clarification. So triangle ABC and CRB, the common base is AB.
And which one? And CRB.
Yes.
No, they don't have a common base. But their bases are on the same straight line.
Okay, yeah, that's what I'm saying.
Yeah. Okay, so here, please can you pay attention? So remember, I called this one x from the previous diagram, and that one what? 2x. And we had k here, this was 2k, and this is what? 5k. So if I want to carry on here, all I have to do to get this, okay, I'm going to say this is equal to, if you apply what I wrote there, you can write here, area of triangle. Remember, we identified the triangle, I'll call it BCR. Triangle BCR over, okay, triangle ABC times, okay, times triangle RCT over triangle BCR. Okay, sorry, I'm supposed to write area. Please bear with me, this is supposed to be area of, that will be area of, please put area there. So this will be area of, okay, please take note that that's area of. So it's area of triangle BCR divided by area of triangle ABC times the area of triangle RCT divided by the area of triangle BCR. Do you see that these two here and those two, they cancel out and you go back to that? Do you see that? But it will help us to solve the problem. Okay, I'm going to carry on, but some of you it's like, okay, so I'm going to move on to that. Now, the area of triangle BCR, I think I have to go to the next page probably. Right, let me go to the next page to avoid overcrowding my stuff here. So if I go to the next page, so my area of triangle RCT over area of triangle ABC is going to be equal to. Now BCR, okay? I'm sure you can agree with me that already I said if they share a common vertex and they have a common height, it means the ratio of their areas will equal the ratio of their what? Bases. So these two, the ratio of their areas will equal the ratio of their bases. Okay? So what is the base for BCR? It's gonna be what? BR. What is the base for ABC? It's gonna be x plus what? 2x, which is what? 3x. Okay? So I can write here x over what? 3x. Okay? Times. Now, these two, triangle RCT and triangle BCR, they share a common height as well. So the ratio of their areas will be equal to the ratio of their bases. What's the base for RCT? Okay, this is RCT, is going to be TC, which is 2K plus what? 5K. So we are going to have 5K divided by, okay, divided by BCR. Now, BCR, its length in terms of K, the base is going to be 8K. Do you see that?
Yes.
Sir, the other one is 7.
Sorry, it's what?
5K plus 2K.
Okay, that's 7. Right, we'll fix that. So that's 7K, and that will be 8K. So, I'm almost done now. So this x and that x cancels, the k and the k cancel. So you end up having 1 over 3 times 7 over 8, and the answer will be 7 over 24. Okay. If you want to say something, you're more than welcome to do so. Yes. Huh? Okay, any question?
Okay, other than that question.
Okay, you can't use calculations, first thing. Right? The concept that you have to use is geometry triangle. That's why my first lesson I studied is triangle geometry. It's very complex. It's not that simple that you can say, this part, then I'll put the area, then I'll put so it's more than that. So we can identify dimensions, then how I'm going to name parts. So we have the trapezium and the triangle. Right. Now, if you look at the ratio, right? It's too large. It's too large as well. By observation, you have RCT. Look at the original diagram, right? Look at the original diagram. Think about it carefully. If you look at this, so you are saying this area here is 2/3. Okay? It's 2/3 of ABC. That's what you are saying. Yes. Remember, ABC is the radius of the two triangles.
No, you did not.
So what it means is the same
I can say
Do you understand what I'm saying? Because the radius of the two triangles is what ABC and RCT inside ABC. So whatever ratio you have, this large. Of which by observation that RCT cannot be more than half of ABC. Okay.